Cartesian product, product of two tables, combining two tables, even the rows and then the column, that is called as Cartesian product. How we are representing a union operation? By the symbol U. And how the syntax will be? A union B. If we want to find the name of the student attending the regular class but not the extra class, we have to go for set difference operation. Hello everyone. Welcome to one more session on the database management system. Myself Induje, Faculty of Computer Science Department, Vidhyaashram First Grade College, Temple of Excellence, Mysuru. Today we are going to learn or we are going to discuss about relational algebra. What is relational algebra? Algebra means what? Algebra means any calculation related or mathematical calculation. We consider it as basic mathematical calculation. We consider it as algebra. How we are doing the algebraic operation in the database, that is relational algebra. When we are providing the relationship between two tables, we have to communicate with the two tables. How operation can be done on those tables, that all we are going to discuss in today's session. What is relational algebra? The relational algebra is a procedural querying language. It consists of set of operations that take one or more relation as an input and produce a new relation as a result. As it is exactly like as A plus B is equal to C. We are taking two relations and we are producing one more new table. Here A is one table, B is one table. A plus B resulting what? C. That is a new table. The relational algebra is a procedural language. It means that it tells what data to be retrieved and how data to be retrieved. What the user or the system designer want to take a data and how we can take a data. Relational algebra works on the whole table at once. We so do not have to use the loops. We are not using any types of loops here because complete table we are working on. So all we have to do is that specify the table name from which we need to take the data and a single line of the comment. Relational algebra will transverse the entire given table and fetch the data for you. What exactly we are doing? We have to just specify one table name from which data has to be taken, and what data has to be taken, that we have to specify using what? Querying language. So relational algebra help us to do such querying. Okay, these are some of the fundamental operations what we have in the relational algebra. Select means whichever the record you want to select, that is called as select particular student from the student database. That is the purpose of select. Project. Select works on the tuples, that is works on the rows. When it comes to the project, it works on the columns. Okay, whichever the column I want to display out of the complete table, I can display only two table or I can display one table or how many required. Union operation. Union means what? Combining two things. Combining two tables together using union operation. Set difference. Difference means, as all of you know, what is the difference? It should be present in one and it should not be present in another. That is called as a set difference. If I am taking the two table A and B, the content which is there in the A, that will only be displayed. Content which is there in the B, that not will be displayed. Then Cartesian product. Product of two table, combining two tables, even the rows and then the column, that is called as Cartesian product. Rename operation. Rename, if I am using the student database, I want to rename that student table as a stud or student 1 or student 1, 2, 3, something like that. I can use this operation. And these are all the basic operation what we have in the relational algebra, and most of the time what we use. Apart from that, we have some different and additional operations. Those additional operations are set, insertion, join and assignment operation also can be done using the relational algebra. Next, let's see one by one. Select operation. What select operation do? What this symbol is? In this symbol, they are going to represent as a select operation. If I do this sigma, sigma. That means you are indicating the compiler or the computer that you have to go for select operation. Select operation selects the tuple. Tuple means the rows in the table that satisfy the given predictions. Use the lowercase Greek letter sigma. This is a sigma, okay, to denote the selection. How is the syntax of the selection? What is the syntax of the selection? This represents the selection operation. This is a selection condition. I want to select on particular condition. I want to select the student who has scored more than 75 marks. So this is a condition. Marks should be greater than 75. So this is a condition what we are giving. Condition on what? On some relation, that is table. On which table I am giving? On table student, where the marks will be stored. Okay, this is a definition, syntax for selection procedure, where the symbol sigma used to denote the select operation, and the selection condition is a Boolean expressions specified on the attributes of the relation R. Attributes of the relation means attribute is here marks, relation is a student. R is generally a relational algebraic expression whose result is a relation that gives one more table for us, that is one more relation it will give. This is used to fetch the rows from the table which satisfy the given condition. We are fetching what? One complete row depending on this condition. Okay, next what we have in the select is sigma is the prediction for select operation. R stands for relation, that is a table which is the name of the table, and P is the preposition logic. Preposition logic what we are using. Here see, this is a selection operation. What is the condition they have given? Selection condition, age should be greater than 17. From where we are taking? We are taking from the table student. Understood? This will fetch the tuple rows from the table student whose age is greater than 17. This is how we can write the select operation in the SQL statement. So taking an example, here I have a one particular table, say branch name, loan and amount in the loan table. In the employee database, employee table will be there, loan table will be there, department table will be there. In that we are taking one table called loan. What is the name of the table? Loan is a name of the table. What is the input? We have to select something. Select the branch name of this from the table loan. This is what? R. Right. Select from what I have to select? I have to select branch name. How many attributes I have? 3 attributes. Branch name, loan number and then the amount. 3 attributes are there. I want to select only the branch name as per right. So this is what? Selection condition. This is selection condition from table loan. So what would be the output? Output should be, it has to select this complete row, and where else we have? Here we have one more condition table. So it is selecting 2 rows, complete rows from the given table. This is all about select operation. How to write the select operation? This is how we are writing the select operation. Select condition from which table we are selecting, and this would be the output for that. Next operation what we have is projection. Projecting, it works on what? It works on column. Projecting particular columns from the table or from the relation, that is called project. The project operation is used to project only the certain set of attributes of a relation. In simple words, if you want to see only the name of all the student in the student table, then you can use project operation. I don't want student age, student address, student phone number, student marks, anything I don't want. In complete table, I just want only the student name. At that time, we can use a project operation. So it will only project and show the column or the attribute asked for. So for example, how we can write the project operation? The syntax for the project operation is what the symbol is called. The symbol is called pi. Okay, this is a pi symbol that is used to represent the project operation. Project, which column we are supposed to project? Column name, column 1 or column 2 or so on. How many columns you want? You can select. From where? From the table name. Every time you should specify from where you are selecting or from which table you are projecting. Table name is very important. Okay, let's see the example for project operation. Example, this is for project operation. This is what we are fetching. I am fetching first column, that is name, and I am also fetching the one more column, that is age. Okay, so here from where I am fetching from student database. What all we are fetching? Student name and student age we are supposed to fetch. So this is a input table, that is a student table. What in the student table we are supposed to display name and age. Here we have one more example. How many columns are there? Name, street, and then the city. Out of these three columns, I want only the name and then the city of the customer. That is what they are doing. Input is what? Project, name and city. From where? From the table customer. Okay, this is what the project operation. What should be the output? Out should be only this column and then this column. Let's see what would be the output here. You can see the output here, right? The name and the city from the employee table will be displayed. How many rows we have? 1, 2, 3, 4, 5, 6. Same rows should be present here. Here also. 1, 2, 3, 4, 5, 6. This is complete set of attribute name and complete set of attribute city. That what we are projecting. Next operation what we have is union operation. This operation is used to fetch the data from two relational table. So for select and project, what we are doing? We are doing the operation only on the single table. Either it may be student table or it may be in the employee table. We are fetching the data from only one table. Here when we come to the union, here two table must participate in the operation. As an example, I can do A plus B when there is two variables. In a single variable A, I cannot do add operation, right? Similarly, here to do the union operation, you need two tables. The tables are temporarily related, result of another operation. For this operation to work, the relations specified should have the same number of attributes, same number of column it must have. If I am saying A is having two columns, B must also have two columns. Then we can do A union B. That resulting what? Resulting one more relation called C. Union operation is symbolized by the symbol U. How we are representing a union operation? By the symbol U. And how the syntax will be? A union B. A is one table. We are doing what operation? Union operation with the table B. So here we have an example. This is what? Project operation. Project the regular classes from the student database and project the extra classes from the student database. Combining from the student database how many regular classes are there and from the student database how many extra classes are there. We are combining together and we are providing total how many classes are there. Next we will move on union operation. In union operation, example, they have taken depositor relation. What the table name is? Table name is depositor. How many rows we have? 1, 2, 3, 4, 5, 6, 7 rows we have. And we have how many column? 1 and 2 column. Let's take one more table because union operation works on two table. In one more table, what we have is same 2 columns, 1 column, 2 column, and how many rows? There in the previous table you can see 7 rows. Here also 7 rows, 2 columns, 2 columns. Now what should be the input? Project customer name from borrower table. Okay. Union with what? Union with the customer name in the depositor table. This table is what? Borrower table. And this previous table is what? Depositor table. What they are asking? They are asking to project the customer name from the depositor and also the customer name from the borrower table. What should be the output? We are supposed to produce or project only the column name from both the table. Here 7, there 7. So whichever the common, that will be kept as it is. Whichever the new, that will be added extra rows. So here how many rows we have? 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 rows. Combining both together, we must have 14 rows, but as some names are repeated in both the table, that will be displayed only once. So how many rows will be having? 10 rows will be having by combining two tables, that is depositor as well as the borrower. Next, what we have, the operation is set difference. This operation is used to find the data present in one relation and not present in, this is very important, not present in the second. We are not taking the common, we are taking the data present only in the one table and the same data should not present in the table 2, which is unique in the table 1, that much only we are taking. So this is a operation also applicable on two relations. Here also, like union operation, we must have two tables to operate this particular operation. So syntax A minus B, that is difference. What we are representing difference with the minus symbol, where A and B are the relations. What all the relation? A is a table 1 and B is a table 2. Okay, we are performing this operation on two table. Example, if we want to find the name of the student attended the regular class but not the extra class, we have to go for set difference operation. So how we are going? Regular classes, we have to fetch what? Student name from the regular class minus what? Student name from the extra class. So it will give all the students who are present in the regular class but not in the extra class. One more example, we look into input what? Customer name. We have to fetch what? Customer name from the borrower. Intersection means minus the customer name from the depositor. It means that what? You have to find only the customer who are in the borrowers, which is common from borrower and the depositor, that should not be projected. Okay, here we have two tables, that is customer table, that is depositor table, this is borrower table. Borrow table, right? See here, John present here, John is also present here. Smith present here, Smith is also present here. Mace present here, no, Mace is not present here. It is present only in the one table, so it will goes to the project operation. Then Turner present in the second table, no, it will also goes here. And then the Jones present here, yes, John's present here. John's also present. John we have already done with the John. And then Lindsay present here, no, Lindsay is not present here, so it will go here in the one more table. Understood? Next what we have is Cartesian product. What you meant by Cartesian product? Combining the both rows and column of two tables or two relation. Here also, as the previous operations we did, two table to perform this type of operation. This used to combine the data from two different relations into one and fetch the data from the combined relation. After combining A and B, I am getting one more relation C. From this relation we are used to fetch data. Okay. So for example, if we want to find the information for the regular class and extra class which are conducted during the morning, then we can use the following operation. Whichever the class, both regular and extra classes combined only in the morning session, that we want to fetch. At that time we can use the Cartesian product operation. So what we are doing here, we are using select operation. Select time. What is the time? In the morning, as given in the statement. From what? Regular class as well as a extra class. This is a notation used to represent the Cartesian product. That is, multiplication symbol is used to represent the Cartesian product. Example, what we have is employee and then the department. We have a two table. Combining these two tables using the Cartesian product. What we have, the attributes in the employee, employee ID, name, and employee department, department number, and then the department name. When we go to the Cartesian product, the resultant relation or the resultant table will be with all the attributes, that is 1, 2, 3, 4 and 5. In the previous slide you can see in first table we have 1, 2, 3, 4 and 5 columns. So all the columns will be put in only one table. That is, all the 5 attributes comes in single table and all the columns will comes in single table. That is what I said. It's a combination of combining both rows as well as a column. That is called as Cartesian product. Next, what we have is rename operation. In this operation is used to rename the output relation for any query operation. As so much of operations we have done, that is A plus B, A minus B, A union B, so many operations we have done. This is C, C, C. All the resultant will be C. When the resultant of this resultant table name is C, it will be again the complication. So what they are telling, this rename operation used to rename the resultant. Instead of C, I am putting it as D. Instead of C, I am putting it as E. Like to rename the resultant table, we are using the rename operation. The syntax of rename operation, this is a notation what we use to represent the rename operation. That is a relational new name. What is the new name you want to give for that particular table and what would be the old name that existed before. First you have to give the new name, then you have to give the old name with the relation rename operation for the relation. So example, we can use the rename operation to the student relational to the student 1. Instead of student, I am renaming it as student 1. That is a example what we have. After relational operation, we have some additional operation like assignment operation. These operations enhances the expressive power of the relational algebra. So far what we have studied is a basic operation. You have to do those operations to fetch the data. These additional operation is to enhance the database or enhance the relational algebra in the database. Additional relational operations are aggregate function, recursive function and then outer join. That is totally we call it as join function. We'll discuss the join function in coming sessions and these aggregate function also. Thank you.